All right, so now we want to map this. We want to map this shared memory into this place here. When I created this shared handle, did I not specify the size of the memory? Is that not a thing you specify? One second, let me see. I'm getting a little lost in the sauce here. What are the things? Maximum size low. Right. So we just wanted to map one page. The size of the shared memory region is a single page size. Okay. All right. I was just testing you. Okay, so now here we go. And by here we go, I mean I'm looking back at the documents. Map view of file EX plus alpha. So this returns a pointer. If the pointer is null, I assume that will be bad news bears. Okay. Auto. P shared is equal to map view of file, well, 2, 3 from app, EX Numa, Mayaha, shared handle, desired access. Is that not just this one? I think it's just the same one, right? Am I incorrect? No, that seems fine. No. Nope. Is a different enumeration maybe? File map. Yeah, it's different than that other one. That was for, yeah, that's a different thing, Chili. Why would you think they would just use the same thing? They obviously are going to use a different thing for the same kind of. Okay, what's the next thing? Numbers. DW file offset high file. So I guess we can map, and then so we can have we can choose the offset into the shared memory, and we want to start at the beginning. So that means 0, 0. And then how much we want to map, number of bytes, which is info.dw page size. And then here's the special sauce. The base address. That's the P page that we calculated. All right. And now, if P shared is equal to null pointer, failed to map shared into memory space. All right. And I guess if we have a failure here, we should want to close handle. Not that it matters. This is where you really like to have, exceptions and smart pointers and stuff like that. But whatever. We can't have nice things. Okay. Map view of file. All right. So this should not work, right? This should definitely not work. There is no universe in which this works. Let's go. Great. Okay. So mapping is created. Vector is created. Pointer. Where's my locals? There we go. Pointer to the buffer. Here. Lots of asterisks, which I guess is 42. The more you know. Yeah. Okay. I mean, that seems good to me. Now, pointer to the page. So this address here is a multiple of 256. But it is maybe not a multiple of the other one? 4096? I don't know. Let's try it out. So we go back. Yeah, okay. So this is a multiple. Yeah, and it seems like they're 3 hexadecimal. So the low 3 hexadecimal digits are the wildcards. And then starting at the 4th digit is the page number, if you want to call it that. I don't know. You know what I mean, probably. Copium. Okay. Now we're going to try to map into this memory. And of course it doesn't work, because why would it work? It doesn't make any sense that memory is being used. You can't map something into virtual memory space that's already being occupied by a different page. So let's just check the error name. So we'll go into watch 1. Error mapped align. Oh, the base address or the file does not have proper alignment. Okay, so my alignment math was, kind of scuffed, which is annoying because I don't want to do any more of that. So this is inconclusive until I fixed my alignment. The results of this experiment are still inconclusive. So how do I fix my alignment? Well, my assumption is that the DW page size is the alignment. So that could be incorrect. Or my math could be incorrect. Let's try it again. Yeah, get rid of that. Go. Buffer, where's my locales? 1700 hexadecimal. Here we go. Yeah, okay. So, where's my calculator? Do I have a calculator button on this thing? I do. Scientific. Programmer. Okay. So like... So 4096 is hex 1000, which means this should be aligned to 4096 alignment. And yet, it's telling me my alignment is bad. So there are 3 things. Either this number is not in the alignment that I need, or somehow this math is wrong even though it looks correct, or this error is actually used also if the virtual memory location is occupied. That doesn't seem correct. Doesn't seem like something they would do, but you can never put it past these guys, these slick guys at Microsoft. So, this is unhappy. I mean, I was hoping that I would just be vindicated outright instead of hitting my head against brick walls, but I did not want to get rid of that thing just yet. Error mapped alignment, copy value. The base address or the file offset, which is normally 64 kilobytes. Get system info. Okay, so if it's 64 kilobytes, then the page thing that I was looking at was the wrong value, which is one of the options that I had specified. All right. My bad. Let's take a look one more time at what is actually in the info. See if there's a 64K value that seems to correspond. Info. So there's a 64K as active process doesn't seem. Allocation granularity. All right. So the allocation granularity is different than the page size. Good to know. My bad. Now, the question is, I think page size is good for the size of the allocation, but we'll just put it at allocation granularity. You know what? Allocation granularity. I don't want to mess around with things that may or may not be correct. It shouldn't matter, to be fair, to be honest, but so now we do allocation granularity. Allocation granularity, this will align it to that amount. Now we're going to map view of file. And this one should be allocation granularity times 4. Doesn't need to be 4. It could be smaller than that, but probably 2 would be enough, but we'll leave it at 4. No, we're going to put it down to 2. I lied. No, we're going to leave it at 3. Okay. Okay, now this should work, right? This should work. This is going to work. Of course it's going to work. Okay. So now we've got more zeros. We've got like another 0 here, which makes sense because 4096 times 4 is 16. Wait, 16? 64? Never mind. Times 16. Yes. 4 times 16 is 64. There we go. Binary hexadecimal mathematicals. Map. Okay, now we're going to get an error, but it's going to be a different error. It's going to be the error that I expected. It's going to be the error that she tells you not to worry about. Invalid address. Attempt to access invalid address. Okay, so I believe this one indicates that that is already being used. Let's see if someone has run into the same problem. Not problem, but no, that's not. Why did you not copy the thing? Copy value. Thank you. Virtual alloc EX. Okay, this is one thing that maps things into virtual memory. Takes a pointer. Problem with allocating memory space is it needs enough room at that when you request memory, you let the OS decide where to put it. So basically, this error comes out of a conflict because the regions in that memory that you requested are already allocated for something else. And I am at last vindicated. So yeah. There we go. So, this is why we can't have nice things. We can't share something that is pre-existing in code that has been created in the heap. If we want to share a region, we have to create a special region for that separately, and that will not be on the default C heap. We will have to do allocations in that region manually by some kind of mechanism. So, yeah. I told you so. Now, I've actually created this shared memory and I've tried and failed to map it, but I've actually proven that I know how to share memory between processes. So I think that would be a fun thing to do since we've already gone this far. Let's actually try to just share some memory between processes by any means that works, by hook or by crook, as someone I know is wont to say. So, yeah, next video, I'm going to do some actual sharing of information over shared memory for once. Until then, bye-bye.